on a half-life graph, what you've got in this area here, let me choose a wee pointer here. Okay, I've got my pointer. In this area here is counts per minute. And what this really should say is corrected counts per minute. Corrected counts per minute. Because it was corrected for what? What was it corrected for? Okay, so we've got corrected count rate in this area here. It's corrected for background radiation. That means the background radiation that would be there anyway is subtracted. Along this axis here, we've got time. And in this case, it's measured in days. Okay? Now, how do we find the half-life from a graph like this? Well, the first thing you've got to do is choose a value on this axis here. Alright, now the obvious one to choose is going to be this one at the top, 80. Alright, so we'll choose 80, we'll choose this value here, and that's, coincidentally, in this case it turns out to be at 0 days. Alright, now to find the half-life, what you've got to do is you've then got to go down to half of 80, which is 40. And then you read across from 40 till you come to your graph, and then you read down. And when you do that, this value here is the half-life. So the half-life for this material is 2 days. Equals 2 days. Alright, now, but we've only done it once. And to be sure, what you should do is you should do a double check. And how you do that is, well, you go half of 40 and go across from half of 40, which is 20. Go across to your graph and come down. And we find this value. Now, it's not 4 days because the start point in this one was here at 2 days. So the half-life is 4 minus 2, which is still 2 days. That's what we got the last time. And then you could go to half again. Alright, so we go to half of 20, half of 10 is 20. Go across to your graph and down. And this time we're getting 6 days, so it's 6 minus 4 is still 2 days. Alright, cool. Yeah? In fact, we can choose any value we like. If we chose, let me get another tool here. What tool would I like? I'd like this arrow tool here. Okay. Oh, lovely arrow, Mr. Swill. Thanks very much. Let's turn it round a bit. We could choose any value we like. Let's choose, in fact, somebody could choose a value. Tala, what value would you like? 60. That's the one I was pointing at. That was a remarkable coincidence there. Tala's chosen 60. Alright. Oh, I need to move my arrow like that so we can see what we're doing. So we can choose 60. Let me get a different colour. Alright, so we go across from 60 to our graph and read down. And we've got a value about 3/4 of a day. And then we go down to half of 60, which is 30. And we read across. And we come down. And it's about 2 3/4 days. So 2 3/4 minus 3/4. Alright, 2 3/4 here minus 3/4 equals 2. 2 days. I put 3 over 3. Thanks very much. I was just testing to see who was paying attention. 3/4 here. That was smart Hamza and smart Ahmed, by the way, who noticed that. The rest of them were sleeping. 2 3/4 minus 3/4 is 2 days. So we've got a half-life of 2 days. And it's as simple as that. That's how you use a graph to find the half-life. In an examination, it'll probably work out perfectly like this one does, but in real life you would probably find that the values were not exactly the same every time. So what you would do is you would go through the process of finding 2 or 3 examples and average them. Okay, here endeth today's lesson.